we're building around people, Jodi. You said it, right?
Yeah.
Like we are here to build buildings for people, and that should be first and foremost in our efforts.
Good. How are you?
I'm okay.
Thanks for joining us.
Yeah, no, it's good to do something other than everything else I've been doing today.
It's about creating an ecosystem.
I'm at an institution that's looking for solutions to the current climate crisis. And we are trying to understand what resources can we bring to bear, and particularly what resources can we bring to bear for some of the most challenging problems. And so my current project is built around using resources from New York forests, so bio-based resources, and creating systems, this is panelized systems, that we can use to improve the envelope performance of our existing buildings. It's great to build new, and I love doing that. There's a lot of buildings that just need to be fixed, right? That could be improved, and we can make a difference. And that's where it's going to have to happen, right? For us to really have an impact on the dial for our future energy use on the building side. And so the system we're proposing essentially is saying, can we do this? And traditionally there are approaches, and most of them are based on using petrochemical foam as the functional insulation in the unit. So what we're looking at is, how can we do this? And in the process, how can we use a product that actually doesn't have a negative embodied carbon impact, but actually is to store carbon? And so there's products in the market in Europe today. We're not using them in the US. There's companies that want to build these in the US. So we're putting together panels, basically 4-foot by 16-foot panels. And so we started building these in the lab. They're composite assemblies using existing wood resources from New York State, along with some wood insulation that's being produced in Europe, but will be produced in the Northeast. We're trying to essentially put together an ecosystem, right? So I'm down in the lab, we're working with the students, we're making sure all the building science is solid, right? It's material that could potentially biodegrade, right? This stuff has to be solidly detailed, solidly composed, solidly thought through. So we're focused on making sure we do that right. But to make it happen and to be able to support a company like yours, Lauren, Chris's, right? This has got to be something where everybody knows how to stick frame a building, right? We've got to, every contractor should know how to renovate using a panelized system for an existing building, right? This should be the bread and butter of a whole group of people. And so we're trying to do that. We're first working on the product, but we're looking potentially at what are all the pieces that need to come together.
There's so much to learn about mass timber.
I'm also have this larger interest in mass timber for commercial construction. For both of these, as sort of imminent as I feel the need is for us to move forward with these, exponentially more concerned am I with having a problem because they're rolled out without being ready. And so in that regard, to answer your question, Lauren, there's a lot that you can do wrong with a petrochemical foam wall assembly, right? And still get away with it, if you will. And that's just not the case if you're using all bio-based materials. Yes. And so where we're at right now, to be clear with you, is we're looking at the trade-off of essentially what is the difference between the economics, the carbon, and the durability risk as you put together assemblies with different thicknesses of material, right? So if we don't use as much insulation, that has a different carbon and economic effect, and it also has a different building performance impact. We're talking about putting a layer of insulation over some type of existing wall assembly. So we're doing some WUFI modeling. This is modeling software that helps us understand kind of the hydrothermal performance. On top of that, we're overlaying it with some descriptors for the carbon impact, and we're using present fuel costs for the economics. Who knows what the economics in the future will be, but we're trying to be very clear about what the current economics would look like. So those are three variables that essentially we want to try to, as clearly as we can, we want to try to narrow down the choices to what we think are locally optimal solutions. And then based on that, we've already built panels because I just want to move forward with that simultaneously. But the panels that we built have not been built upon modeling for ideal insulation thickness. So we're using right now a 4x16 backup panel that's made with thin ply, cross-laminated timber. So what do I mean by that? So this is in New York State. We have about 10 million acres of white pine that is harvested or could be harvested, we should say. And at this current rate, for every tree we harvest, there's 2 trees of production that's growing to replace it. So actually our forests are growing, and our forests are growing at a rate that the removals are not even yet to the point where we're just at equilibrium. We still have more forest building up than we do removals. And so this is the problem they've had out in the western states with all of the forest biomass that's built up from all these years of not doing anything. So in New York, where do we stand? We have white pine mills. They don't produce larger structural timbers like 2x4s and 2x6s. Instead, they produce boards, just 1x boards, finished material. We're taking those, we're adjusting the thickness of them, and we're creating a 4-foot by 16-foot panel that's about 1.5 inches thick. And that's using this local resource, cross-laminated timber. It stays very stable. Over that, we're overlaying this product from Europe that will be eventually produced here in the Northeast. And we're creating this sandwich now. Over that, we've got layers to control air, moisture, and a rain screen. And then over that, we can use whatever cladding you'd like to use otherwise. So we're putting together these panels. We've built 3 of them now in the lab, and we're in the process of testing those 3 that we've built.
Working based on a grant.
We've got, in the current grant, we've got 6 months for feasibility, a year for development, and then after 18 months is the demonstration period. So the demonstration at this time looks like it's going to be a Syracuse Housing Authority building here in Syracuse.
Discovering how nature forests.
We want to make sure they understand what a sustainably managed forest would look like and what nature would do with a forest, right? There would be loss in nature. There would be over time, right? The forest characteristics would change. What are we doing that essentially mimics that approach if we try to sustainably manage the forest? So we're looking in those 3 areas. First, at the very specifics of the forestry and carbon accounting, LCA, product development, and then stepping back a little bit, if you will, and looking at some of the broader societal implications.
I really appreciate what you said about relating this to how a forest would manage itself. Because I think a lot of people still, and maybe this was a fault of environmentalism in the 60s and 70s, think that we have to protect nature and keep it separate from people in order to preserve it. The whole preservationist kind of mantra is quite different than working with nature and working with nature following her own rules, right? So I think mass timber, what excites me about mass timber is some of the things you've touched on. Not only is there a way to create a market and a kind of a closed loop system of managing forests, but there's an ability to do that in a way that aligns with how nature would manage a forest herself, and to reconnect human beings to nature through biophilia, which is something that I don't think we've studied near enough. That's the thing that excites me most is understanding divorcing ourselves from nature has created a lot of stress that we haven't tabulated yet.
No, I agree, Jodi. This is absolutely fascinating, right? You know, intrinsically, what is it that we want to surround ourselves with? You know, and it's easy to say, you know, I want to surround myself with this or that in a consumerist society, but there's actually very deep, right inside of us, there's very deep longings we have about what we want to surround ourselves with, you know, including for some family, including for, right? But, you know, physically, what do we want to surround ourselves with? I just don't think we know a lot about it, right? I just don't think we know enough. And so I agree. I'm absolutely fascinated. I wish I could figure out how to learn more about it, but I think, you know, what we're doing in terms of mass timber hopefully gives people the opportunity to ask themselves that and say, you know, is this what I want to look at when I get up in the morning? Is this what I want to walk on? Is this what I want to run my hands over? Right? Are these the types of things that I want to surround myself with?
It's exciting to offer project support.
So we do have a team here. We want to be kind of project support folks. We know a network of people who also, like Jodi, want to support this type of work. And so, you know, if mass timber comes across your radar as a potential for a project, and you at any time feel some way frustrated by your inability to wrap your head around something or solve a problem in a manner, please don't hesitate to reach out. Those are the phone calls and the messages that I love to get, right, that pop into my inbox, and I will stay up late working on that kind of stuff nonstop. So
First question, what about fire?
Well, just okay, the first thing that occurs to me is everyone's response to building with wood is, well, what about fire?
sure, yeah. No, and it's a great question. We're building around people, Jodi. You said it, right?
Yeah,
Like we
yeah.
are here to build buildings for people, and that should be first and foremost in our efforts. So why would we build with big pieces of timber? And so the opportunity that big pieces of timber present actually is to give us an environment in which we have a very predictable behavior to the structure. And so it turns out that there is a potential in any building, right, that there's going to be some materials that are combustible. And so we want to make sure that we reduce that risk as much as humanly possible. When we build with timber, what we do is we create a sufficient size of timber that effectively makes it very, very difficult for us to start that big log on fire. So using mass timber really gives us a safety in terms of the risk of fire, such that dropping a match will never ignite mass timber, right? Dropping a burning propane torch is going to scorch the surface of wood, but it's never going to catch fire and have a fire that races throughout a building. So we're building in a manner that, with the mass of the timber that we use, would be extremely hard to ignite to the point where the occupants of the building would have to evacuate the building. So the stuff that burns quickly, right, is the stuff that we have to be most concerned about. And it turns out mass timber, if you can get it to burn, is going to burn so slowly and so predictably that you could literally amble your way out of the building, never putting yourself into any possible condition of risk. Firefighters more and more are beginning to understand how safe it is to fight a fire in a building like this. Mass timber building is not a building that's going to collapse catastrophically. They know exactly that they have hours and hours. If they want to use an interior approach to fight the fire, they have hours and hours to do it. Using an exterior approach, they know exactly how the building's going to behave.
How about earthquakes?
That kind of just had me thinking with like earthquakes, for example, because so, you know, in storms, earthquakes, anywhere where there might be force that we're not normally under, or stress that we're not normally under, does a mass timber building also perform potentially better than steel because of rigidity versus maybe something that's, I don't know, you tell me. I don't know, that's what I'm asking.
I'll tell you what, Lauren, if you want to sit for the structural exam for the PE, I will write the letter of support. No, you're right on the mark, actually. So the structural behavior you're describing is one of the potential advantages of mass timber. And so how does that play out? It turns out that in the case of something like wind or a seismic event where the building is being pushed around, a mass timber building is about 1/4 the weight of a reinforced concrete building. Okay, about 1/2 the weight of a steel building. And what it means is that in the case of a seismic event, it's that much less force that the building has to resist. And so a lighter building is easier to keep in place than a much heavier building. And so literally the foundations are smaller, the lateral bracing system is smaller. The wood itself as a material stores energy. So if you take a piece of wood and you hammer on it, as you crush those cells, you've actually absorbed energy from the hammer hitting it. That same principle applies in the case of a seismic event. And so wood buildings are being used widely across the West Coast. After a concrete building experiences an earthquake, there's going to be catastrophic damage. You will no longer be able to use the building. The people will have survived the earthquake inside the building. A mass timber building, the people will likewise have survived the event, and the building itself will have absorbed the energy and can be reused, right? So the building resilience is built in because of the structural material. Those are not such big advantages for us on the East Coast, actually, right? We don't have to worry about seismic in the way they do out on the West Coast. But there are, right, for sites that have tough geotechnical conditions, mass timber actually typically, in urban infills, when you're on poor soils, they put up buildings and there's typically 2, 3, or 4 extra stories they're building on the building, returning money to the owner because of that reduction in weight.
Let's do a little picture painting.
That's phenomenal. I think that there's so much to unpack there. Just back to the fire resistive. I want to paint a picture for people who are not involved with the building industry. Anyone who's lit a campfire knows that the hugest piece of wood that you think you can just light on fire and then not have to worry about the campfire anymore is the one that will never light. So to put that into perspective, the energy that's retained in the wood. Think about if you were taking a hammer and striking something that's steel, you're going to feel all that energy revert back into your arm, and it's going to be quite painful. Whereas wood will take in the energy and absorb it. So that's trying to make that a little bit more understandable for someone who's not in the building industry. Same with concrete. You hit it, you feel the reverb back into your shoulder and your elbow and your joints. When you're hitting wood, you don't feel that in the same way because it's absorbing the energy. The thing that I find
very nice examples, Jodi. Thank you.
Yeah,
oh, yeah.
it's excellent.
The thing that I find really exciting that I hadn't processed before is that the building being lighter means a lighter structure, a lighter foundation, less impact on the site potentially. There's a whole lot of benefit there in reducing carbon, through reducing impact to the soil, through reducing materials that I hadn't connected to mass timber. So that's a huge learning piece for me from this conversation, and I really appreciate that. And I wanted to point out that the idea of a lighter building being more resilient in the case of an earthquake might seem counterintuitive to people. So I want to reinforce that, which is probably a poor term, reinforce that. But anyway, I want to state it again that when a building has less mass, it has to absorb less impact from the earthquake and has an ability to be more resilient and to still be a useful building post event, which I think is the point that was made earlier. I just wanted to state that again.
Connections, as always, are important.
I have 2 more questions now about it.
Jodi, thank you. Yeah.
So what about like hurricane resistance?
ASCE 7, which is the minimum design loads for structures that all the structural engineers know and love, those same loads are going to be applied to the design of any building. What we typically see in wood buildings is it's not unusual in wood buildings for the main structural members, columns, and beams to be made out of wood, but the connections in many cases will still be steel. And there's structural reasons for that. But essentially, if you envision, you described, a hurricane, something like that, Lauren, basically we want to keep this building together, and keeping the building together means making very strong connections and tension. And when you take 2 pieces of wood, using steel sort of strategically at that connection point is a good way to transfer that tension through. So the building can be designed to be identically safe for whatever, weather phenomenon might hit it.
The quick thing on fire. I read also some information about how the steel connectors in mass timber quite often have to be protected with wood in order to survive fire, which is something that is just reinforces again the fact that mass timber is fire resistive in a way that we've forgotten over the last century and are relearning now.
Yeah.
So, back to you, Lauren. Sorry.
And what about termites?
Termites.
Aha.
So termites, essentially, the same techniques we typically use for light construction, if you will, are approaches that are used for mass timber. What functionally, from the building science point of view, many of these buildings, it makes the most sense for a number of reasons for them to be built with podium construction. So Essentially, the first story of the building is built out of reinforced concrete.
Mhm.
And then atop that, we use mass timber all the way on up. And so that's a nice combination of two different materials, right? Concrete with a natural resilient resistance and durability to termites and other biodegradation. And then wood, right, all the way up where it's protected and safe, essentially. So it's not unusual for tall buildings to be built that way. For single story and low rise buildings, many times we want to make sure that we get the detailing right. So this is absolutely something, just like for traditional wood construction, right? It's important that we detail this right. It's important we keep the moisture out of the envelope. It's important that we have the perimeter of the building protected. So it's not unlike light construction in that regard. The good news is there's a lot more wood there, right, that could withstand damage were it to happen.
I think that's a great statement to help us remember that there isn't a one size fits all solution, and there's not one product that's going to solve our carbon future. So it is the materials are at their best when they're used intelligently with other materials that can help create a complete system. And I think that's a marvelous thing to always remind ourselves of.
Wrapping up our time. Thanks, Paul.
Oh, I
Oh,
so much
thank you.
appreciate your time
No,
and your
thank you so
insights,
much.
Paul.
Like I said, I've admired your work from afar for so long. I'm really very honored to be on here. And I think that, the way that we reach out to people has changed over the years. And I'm just really glad that you're doing it this way. I'm really glad that you're creating this opportunity for people. So thank you for those efforts.
If you
Okay.
think of or know anybody additional that you think would be good to come on in a format like this, we'd love to reach out to them.
Yeah,
Okay.
absolutely.
I will do some thinking on that.
Glad you could join us for Subject to Change, a sustainability podcast.
Thank you.
All right. And thank your kids for being the exceptional
Awesome.
people that inspire you.
I know. Yeah, exactly. Thank you so much. I hope you both have a great night.
Yeah.
Take so good
All right.
care. Take care,
Bye.
Jodi. Lauren.
Take
Bye-bye.
care.
Thanks.
Bye.